Hello again, you sick, twisted weather freaks. Welcome to another fun filled, action packed, and intellectually stimulating edition of This Week in Weather. I'm your host, DT from WX Risk, the commander of chaos, the colonel of confusion, the captain of catastrophe. Let's talk about weather. And we'll be talking about the tropics here. And obviously, we're going to be talking about Barry. That's really the entire topic of this particular video. Just remind you, that's how you can reach me. If you ever want to reach me through the my Verizon email, my Gmail, that's the operational Twitter account there, and of course the Facebook page, and a picture of my smiling face. All right. One of the things we like to do I like to think that my mission statement here at Weather Risk is to be thinking outside of the box. So that's kind of a big thing here. So some of the information here you're going to see is kind of unusual, but that's okay. It's simply not, I simply don't do regurgitation what everybody else is saying. I mean, a lot of times what everybody else is saying and the consensus forecast is right, but sometimes it's not. So I like to present different things to the forecast and show you, how I view things, and hopefully spread the gospel of science and critical thinking. All right, this here is the 8 p.m. statement from Hurricane Center, which I'm sure many of you already seen. But as you can see, they are going to investigate it tomorrow, and it is likely that a tropical depression, a tropical storm is going to form here over the next 24 to 36 hours. This is the satellite picture from late this afternoon. You can see this is as of 4 o'clock this afternoon. You can see the system is just, the low level circulation was probably somewhere around, I would think, this area right in here. And you can see the feeder bands already at this point trying to develop here. Um, I think you can see one of them, I guess, right over this area here. You kind of see another one coming in like this. So it definitely has some sort of circulation here. There's no doubt about that. Okay, then we have another satellite picture, one later on this evening. This was as of 7, 7:30 this evening. You can see right o'clock. You can see again the center is actually a little further to the coast, just about here. So it definitely is drifting into the Gulf of Mexico, as the models have been forecasting. So that's good. The models are not blowing that in terms of the system moving into the Gulf of Mexico. Remember, this thing started way up in Missouri and Illinois, so it's gone quite a track. Now, this is the latest sea surface temperatures, and you can see the ocean water temperatures in the Gulf of Mexico are somewhat above normal. Not in the northeastern quadrant, not super warm above normal, but half a degree or so, a degree above normal centigrade. So that's kind of warmer than normal. Now this was the European model from this from a Tuesday morning, and you can see where the low is centered. I'll make sure you can. Let me call it up. You can right here. That's where the low is, right in this area here, and it looks pretty impressive here. It's almost a borderline hurricane at this point. It may even be a Category 1. It makes landfall in this whole area. So that's what the 0Z GFS, 0Z European was showing. And from the rainfall, what it was doing is the model was taking the system right up the Mississippi Valley, as you can see here, and bringing tremendous rains up into this whole area. Now, it's been drying out in these areas recently, and many areas in this part of the Midwest here could use a good drink of rain. So this would be pretty significant if it would come up and do that. And of course, if it does that, you notice here in Virginia, North Carolina, South Carolina, Maryland, it misses everybody. So that's what the 0Z, okay, the early Tuesday morning model is doing. All right. Now, this here is the afternoon run. Let me call it up here. No, before I get to that, excuse me. Now, this is the problem. This is the European ensemble. Now, look at the rainfall there and look at it here. Now, what's happening is the European ensemble is not taking it this up like this. It's taking it and bending it much sharper to the right here. And that poses a threat for the rain getting into the middle Atlantic region. So these are two very different solutions. And the reason is because you'll see the ensembles have this big dome of high pressure that builds in here. So I had a great deal of difficulty believing it's going to get into Missouri. I think it's going to bend to the right. And we'll see that and why, other reasons besides the models that I think that. All right, now this here, next slide, this is, again, this was the 0Z run. Now here is the 12Z run from this Tuesday afternoon. And you can see the low, again, in eastern Louisiana to the west of New Orleans. Now, obviously, if the track were to come in like this, that would place New Orleans in Lake Pontchartrain in the northeast quadrant. Again, just as a Category 1 hurricane, but it would definitely be flooding problems. This would be a bad track for a Category 1 hurricane for eastern Louisiana. There's no two ways about that. And then it takes it, again, the afternoon run, as you can see, takes it right up into Arkansas, still doing that stuff. So the operational European is consistent. Now, this is hard to see what the actual pressure is. So when you look at this image here, again, this is the 12Z European operational run. You can see it says, oh, let me go back here. It says 984 millibars. Okay, and again, New Orleans, just to give you an idea in case you don't know where it is this is Lake Pontchartrain. So there you go. So again, it places them in the eastern quadrant of the system, which is not where you want to be, even for a Category 1, given their flooding problems there. And then, of course, the afternoon run, there it goes, takes the heavy rain up into the Delta, then up into eastern Missouri, Illinois, Kentucky, Indiana, Ohio. And you can see it bypasses most of Maryland, Virginia, North Carolina, and South Carolina. But again, look at the European ensemble. Same thing. Okay, that was the morning, that's the afternoon run, right? And this was the morning run. The ensemble is not changing. It keeps saying no, the operational run is too far north and west with the rain. That and that are not the same. They just aren't. So there you go. That's something to keep in mind. Why it could get into the rains could get into the Tennessee Valley and as opposed to the Ohio Valley and into North Carolina and Virginia, Maryland, and Delaware. Okay, we're just talking rain to this point. We're not talking any big storm here, okay? Make sure you understand that. Now, this here is the operational European probability of a tropical depression, winds greater than 20 knots, which is about 25 miles an hour, in the Gulf of Mexico over the next 4 days. And the very high probability is something you can see that nearly 90 to 100%. And that this is tropical storm probability. And you can see, again, over the next 4 days, 90 to 100% probability south of New Orleans, really, in the north central Gulf of Mexico. And this one shows the probability of tropical depression winds and the remains of the system, as you can see, getting up further to the north. Now, notice we have like 40% probability, 50% probability in Virginia, West Virginia, Kentucky, southern Ohio. So there's this possibility, again, that the remains and some gusty winds could get into this portion of the country. Okay. All right, slide 20. My next slide here. Now, this here is the latest El Nino. We can see that the El Nino conditions, this is the CDAS evaluation of the El Nino, continues to weaken. It's almost at neutral conditions. And this on the bottom right image, this is the TAO data buoys. You can see that the warm water at the surface, this is along the equator. So in case you don't know how to read this, let me briefly show you. This is going down underneath, okay, 100 meters, 200 meters. This is the equator right here, the surface of the equator where the boats are, okay? So you can see there's a little bit of cold water, warm water here and a little bit here, but look at the big buildup of cold water here. So this El Nino is rapidly breaking down, and that's important because a lot of the hurricane forecasts early on were counting on El Nino this summer, and that's not happening. We saw that in 2017. Everybody thought we were going to have an El Nino that summer, and it broke down, and suddenly we had these monster hurricanes, and because the El Nino wasn't around. To show you the difference and why this is important, now this shows you the probabilities of seeing hurricane landfalls depending on El Nino, La Nina neutral conditions. So the black box here, that all represents when the water is cold, so La Nina. Okay, so let's look at the East Coast, for example, here. On the East Coast, you can see that when on the East Coast, the probabilities is like 0.72. That's pretty good. For Florida, almost like a certainty of at least one hurricane hitting you during La Nina years. The Gulf Coast, very high. And then all regions, again, you average about over two hurricanes making landfall. When you have neutral conditions, 1.65, a little less. And also you can see there's a drop here and on the East Coast in particular. And then when you have El Nino conditions, that's El Nino right here. See the warm water? Look how low the probability is here. Big difference here on these numbers. Look at the drop off here. Wow. Big drop off. So the fact that we're losing the El Nino is an ominous sign for the hurricane season. That's my point here. Let's take a look at the MJO for a second, and I'll tell you why. Because here we have the European model on the left, the Japanese model on the right, and they both show that over the next 10 days or so, the 12 days, the MJO is going to be in phase 1 and maybe into phase 2 if the Japanese model is correct. And the reason why that's important is because of this. Now this image here, shows you the connection between MJO phases and landfall. So for example, as we can see right here, when you're in phase 1 and 2, okay, look at the chances of seeing a named storm, Okay, and look at the numbers, named storm days. You can see the very high here, hurricanes, hurricane days. Okay, look at phase 6 versus 7. Very low number of times you've had a hurricane, or a major hurricane is also quite low. So you can see there's a big difference. Phase 1 and 2 clearly favors a hurricane development or tropical storm development. And phase 6 and 7, as you can see, favor does not. So the reason why that's important is because, like I just showed you, let me go back up here. We are in phase 1 and 2 over the next 10, 12 days. That favors tropical development. Number of named storms, named storm days, hurricane days, named hurricanes. It's just overall difference. And so that's quite significant. Another thing that I look at, which nobody else does, this is research, of course, which is done by different people in the weather forecasting, Journal of Climate, and other AMS periodicals you can get. Now, this is the hurricane cluster tracks. And there are, generally speaking, there are 4 different clusters for hurricane tracks. You have 1, 2, 3, and 4. And obviously, cluster 1 right here, this clearly favors development, as you can see, in the southeastern U.S. or the Bahamas. And then cluster 2 is Gulf of Mexico. Cluster 3 is Cape Verde. And cluster 4 is Caribbean. So, and you can see where the development is here. Caribbean, Cape Verde, obviously tropical Atlantic. Cluster 3, Gulf of Mexico. And cluster 1 in the Bahamas and off the southeast coast. And again, you can see with landfalls clearly favor, so on and so forth. So this is a very useful track because those clusters are heavily influenced by the MJO. So when you are in phase 1 and phase 2, you can see that the different phases refer to the different clusters, A, B, C, and D. So for example, in phase 2, you have really the ones which are most favored are cluster 1 and cluster 3. Different colors. Here's cluster 1, there's cluster 2, cluster 3, so on and so forth. When you're in phase 8, in phase 1, again, you can see which ones are more likely to happen. So by knowing the phases and the cluster tracks and the MJO phases, you can get an idea of what track is likely to happen when this tropical storm begins to develop. So you're not simply using the models or guessing. You have an idea. You can use climatology and real MJO analysis to figure out which track is most likely to happen. So that's one of the reasons why I like using this stuff. It's really, really useful. Not everybody uses it. Here's another way of looking at it. Let me shrink this here a little bit so you can see it. There you go. Again, if you look at the month of July here, month 7, there you go. You can see the purple, which is cluster 1, is most heavily favored, followed by cluster 2. If you look at May, June, and July, the most active cluster is 2, and then in phase 1. So again, okay, phase 2 and phase 1. Phase 2 is our Gulf of Mexico development. There you go. And that's exactly what this thing's likely to do. So this is amazing how this works out. It really is quite a useful tool. Now this is the official track from the Hurricane Center, hurricane models. As of midday today, you can see some of the tracks still had it going towards Texas a little bit, but most of them are showing a landfall in either Mississippi or Louisiana. And then this is the new one, just came out for this Tuesday night, Wednesday morning, and you can see again very few tracks making landfall to Texas. They all favor either Mississippi or Louisiana. And look at the sharp turn to the right of some of these tracks. Look at this turn to the right here, and a lot of these tracks like that. So we're not seeing this. We're seeing this, and that's, I think, a significant turn. This here's the European model, and this has been showing this for a while. This is the 12Z run, but the afternoon run, the early morning one, European Tuesday morning, showing the same thing. Again, look at the sharp turn to the right, and notice the number of lines that go through Virginia and West Virginia, Kentucky. So again, rains are definitely a possibility getting into it, into the lower mid-Atlantic here later on next week. This here's the GFS ensemble, the 18Z run, and also you can see very big cluster of concentration here over southeastern Louisiana. Some just to the west of New Orleans, some over New Orleans, but that's a pretty big cluster of concentration there. Now let's talk about the models, why this is happening. Let's do some model analysis. Okay, the upper left model, this is for Tuesday evening here. And you can see this is the 12Z run of the European on this Tuesday, but you can clearly see the feature. Now the system is somewhere here. It hasn't really developed. But see this trough here? This big trough right like this. Now look what happens. This is now Wednesday evening right here. We're talking Wednesday evening. See the trough here? Now look at this big dome of high pressure over the Rockies. Now this is the system. This is Barry. Now, is Barry going to get caught in this trough? Or does it get turned this way underneath the ridge and go into southern Texas? That's the question. Or does it drift towards Houston and maybe Lake Charles in western Louisiana? These are all different possibilities. Now, the operational models clearly show the trough now weakening as it moves into the East Coast on Thursday into Friday. And we can clearly see on this upper left map, there's Barry right here, and there's the dome. Look how big this sucker is. It's enormous, right? Now here's our trough. Okay. Now Barry's turning north because it sees this weakness here. It sees the weakness. It says, "Oh, there's a place for me to go. I think I'll go there." And you can see it begins to turn. And then the bottom right map. This is the European ensemble for the same time frame. And you can see we're in pretty good agreement here. The trough is moving to the East Coast. Barry is turning to the north. Now, next slide here, this will take us, oops, let me clear out the images here. And now this takes us to 96 hours. This is Saturday morning. Now Barry's about to make landfall. Okay, the trough is now off the East Coast here, as you can see. And look at the dome. The dome was moved in front of Barry like this. You see that? So this should block it, but it's going up against it anyway, according to the model, which I think is a little bizarre. I don't understand the reasoning here of what the model is doing. Now, if we go here, we can see the European now for Sunday morning has it in Louisiana, pushing into the big ridge, and then finally it splits it on Monday morning, July 15th. And you have the big rainstorm in Arkansas going up to Missouri and Illinois. I think the solution is nonsense. I think it's way too far to the west. And indeed, if we look at the European ensemble, we can see that it already looks like it is turning this direction. This big dome here is going to block it, and it's going to be forced to go in this direction. This is where the weakness is in the jet stream, folks, right there. You see that? So it's going to turn towards the weakness. I don't think it's going up to Missouri, Illinois. I just don't think that's the correct solution. I could be wrong, but that's how I see it. So in summary, how fast does Barry develop? Remember, weaker tropical systems, like a tropical depression, tropical storm, tends to follow the low-level winds as opposed to the upper-level winds. That would mean if it stays weak development, it's more likely to stay west and possibly stay off the Louisiana coast and head toward Texas, maybe northeastern Texas. That's if it misses the trough over the Great Lakes. It might not, but it might. So again, we have to think outside of the box. We simply can't assume the models are going to be correct here. The models are showing us the pieces. We have to consider all the possibilities. Okay? Point number 2. If the Great Lakes trough misses Barry, the tropical cyclone is likely to go into West Texas coast and then maybe stall or get blocked by that massive dome over the Rockies. That could be a problem for southeastern Texas with a lot of rain, or maybe even western Louisiana. Point number 3. Even if Barry does get pulled north, okay, the trough may still race off the coast and leave it lingering somewhere over the Delta or the Tennessee Valley with a lot of rain and flooding there. That could be a problem. It may also perhaps let it linger on the Mississippi, Louisiana coast, and it doesn't get a chance to go anywhere. And then point number 4. So if the trough does catch Barry and then turns to the north, okay, the system, of course, will at that point be a rainstorm, but then it will follow the trough, the weakness, and it will turn to the northeast, and then northeast into the Tennessee Valley and the Mid-Atlantic. That's point number 4. If the trough completely catches Barry and pulls it that direction. So there are several different possibilities here, and we don't know yet because we don't know how fast Barry is going to develop and the intensity of it, and we don't know if the trough is going to catch it or not. These are all different possibilities. We just have to play by ear. This is meteorologist DT from Weather Risk. I'll do another video probably this weekend. We'll see how things develop then. I'll talk to you soon.